object that's classified as an NEO has an orbit that crosses Earth's orbit, which means it will one day collide with Earth.
Our planet is teetering on the edge of a cosmic catastrophe. Renowned astrophysicist Neil deGrasse Tyson, a voice trusted by millions, has sounded the alarm. In the vast expanse of our solar system, an asteroid named Apophis lurks, and its potential collision with Earth could be catastrophic. On Friday, April 13, 2029, this colossal asteroid will pass within a mere 19,000 miles of our planet's surface, closer than some satellites. But the real question is, what happens next? Could Apophis collide with Earth in 2068, unleashing devastation beyond imagination? And how prepared are we to deal with this cataclysmic scenario? Let's find out.
Then we have the nation busters that'll knock out North America, it'll knock out Germany, it'll knock out the huge portions of the planet Earth.
Apophis, a terrifying discovery. 2004 was a time when our understanding of near-Earth objects was still evolving, and the tools at our disposal were just beginning to scratch the surface of the universe's mysteries. It was during this period that astronomers, using the Kitt Peak National Observatory in Arizona, stumbled upon a discovery that would send ripples through the scientific community. The asteroid, initially designated as 2004 MN4, was later christened Apophis, after the ancient Egyptian god of chaos and destruction. A fitting name, some might say, for an object that would soon become the subject of intense scrutiny and debate. But what was it about Apophis that made it stand out from the myriad of other space rocks hurtling through space? Why did this particular asteroid become the talk of the town, drawing the gaze of astronomers and space enthusiasts alike? The initial observations of Apophis revealed it to be a sizable object, with estimates suggesting a diameter of approximately 1,200 feet. While this might not sound particularly large in the grand scheme of things, in the realm of near-Earth asteroids, it's substantial. To put it in perspective, that's roughly the size of 4 football fields laid end to end. But size alone wasn't the only factor that piqued the interest of the scientific community. Have you ever had a moment where a discovery was so unexpected that it took a while to fully grasp its implications? That's precisely the sensation that swept through the astronomical community upon Apophis's discovery. The asteroid's unique orbit and characteristics made it a subject of fascination. Its spectral type, classified as an SQ-type asteroid, indicated a stony composition with a hint of metal, giving it a slightly reddish hue. This composition, combined with its size, made Apophis an intriguing specimen for researchers keen on understanding the makeup of our solar system's early building blocks. But beyond its physical attributes, it was the data surrounding Apophis's trajectory that truly set the stage for the discussions that would follow. We'll tell you more about that later. For now, let's take a step back. How do astronomers even detect such objects in the first place? The process is a testament to human ingenuity and the relentless pursuit of knowledge. Using advanced telescopes equipped with state-of-the-art sensors, astronomers scan the night sky, looking for moving objects against the backdrop of distant stars. Once an object is detected, its position is tracked over time, allowing scientists to calculate its orbit and predict its future path. But what did Neil deGrasse Tyson, one of the most prominent astrophysicists and science communicators of our time, have to say about Apophis? From the outset, he recognized the potential implications of an asteroid of Apophis's size and trajectory. While many in the scientific community were engrossed in the technical details of the asteroid, Tyson used his platform to raise awareness about the broader implications of such celestial bodies. In fact, one of his most quoted remarks about asteroids is, "The universe is a deadly place. At every opportunity, it's trying to kill us. And so is Earth. But human beings are really good at not dying." And as we delve deeper into the mysteries of Apophis, we'll find that the universe indeed has its own set of surprises. So keep watching. 2029, a ticking time bomb. A startling revelation, the solar system seems to have a peculiar sense of timing. On Friday, April 13th, 2029, a significant event is set to occur. Apophis, a massive asteroid stretching about 1,100 feet across, will make a close approach to Earth, passing within a mere 19,000 miles of our planet's surface. To put that into perspective, that's closer than some of our satellites orbiting Earth. But before panic sets in, it's essential to note that scientists are confident that Apophis will not collide with Earth during this encounter. Instead, this event presents a unique opportunity for researchers to gain invaluable insights into asteroids that come close to Earth. Yet, as we'll explore later, there's an even terrifying twist to this cosmic tale, one that involves the return of Apophis in 2068. Did you know that such a close approach by an object of this size occurs only once every 1,000 years? This makes the 2029 event a truly unique spectacle. Richard Binzel, a planetary scientist at MIT, emphasized the significance of this event during the International Academy of Aeronautics Planetary Defense Conference. He highlighted that the asteroid's size and proximity would make it so bright that approximately 2 billion people could witness its passage with the naked eye. Imagine looking up at the sky and seeing an asteroid, a relic from the early solar system, passing by so close. One of the most intriguing aspects scientists are keen to study is the Yarkovsky effect. This phenomenon arises due to the temperature difference between the day and night sides of an asteroid. The heat emitted from an asteroid's surface can exert a tiny force, nudging the asteroid in a particular direction. While this effect is minuscule, over time, it can significantly alter an asteroid's orbit. For Apophis, understanding the Yarkovsky effect is crucial. Although its 2029 trajectory is well defined, the uncertainties associated with this effect make it challenging to predict the asteroid's path in the distant future. Now, with a decade to prepare for Apophis's close approach, scientists are gearing up to gather as much data as possible. This information will not only enhance our understanding of Apophis, but will also provide insights into other potentially hazardous asteroids. After all, Apophis is believed to be similar to about 80% of the potentially dangerous asteroids that have been identified so far. But here's a thought to ponder. What if we could study Apophis up close? Scientists are already exploring the idea of sending spacecraft to observe the asteroid before, during, or after its 2029 flyby. Drawing from recent successes in space exploration, such as NASA's Mars InSight mission and the Hayabusa 2 asteroid mission, researchers are considering various mission concepts. Some of these include placing a seismometer on Apophis to study its internal structure, or even creating an artificial crater to observe its subsurface. However, with great knowledge comes great responsibility. Given the asteroid's close approach, there's a heightened responsibility to ensure that any human intervention doesn't inadvertently alter its safe trajectory. 2068, the year of reckoning. But what about the future? What if the 2029 flyby isn't the only close encounter Earth has with Apophis? The year 2068 looms large in the minds of many astronomers and space enthusiasts. Why? Because that's the year when Apophis might, just might, collide with our planet. This is where the concept of the keyhole comes into play. Imagine throwing a stone into a pond. If you throw it at a particular angle and speed, it might skip once, twice, or several times before sinking. Similarly, a gravitational keyhole is a small region in space where if a passing celestial body, like an asteroid, goes through, the Earth's gravity can alter its trajectory. In the case of Apophis, if it passes through a specific keyhole during its 2029 flyby, it could be set on a collision course for 2068. Now let's pause for a moment and consider the implications of such an impact. What would happen if an asteroid the size of Apophis struck Earth? The moment it makes contact, the immediate vicinity of the impact would experience cataclysmic devastation. The asteroid, traveling at speeds of several miles per second, would release energy equivalent to billions of atomic bombs. This would result in the formation of a massive crater, potentially several miles in diameter. The heat generated from the impact would be so intense that it would instantly vaporize the asteroid and a significant portion of the Earth's crust at the impact site. This would lead to the ejection of molten rock and debris into the atmosphere, creating a fireball that would incinerate everything in its path. If Apophis were to strike an ocean or sea, the consequences would be even more dire. The impact would generate colossal tsunamis with waves reaching heights of several hundred miles. These waves would travel across entire ocean basins, wreaking havoc on coastal cities and settlements. The sheer force of the impact would also trigger seismic activity, potentially causing earthquakes thousands of miles away from the impact site. Regions unaccustomed to seismic activity might find themselves grappling with unexpected and powerful tremors. The aftermath of the impact would have long-term global consequences. The vast amount of debris ejected into the atmosphere would block sunlight, leading to a phenomenon known as an impact winter. This could last for months or even years, causing temperatures to plummet worldwide. The lack of sunlight would severely disrupt photosynthesis, leading to a collapse of the food chain. Crops would fail, and ecosystems would be thrown into disarray. This would result in widespread famine and a significant reduction in biodiversity. The socio-economic implications of such an event are hard to fathom. Infrastructure would be destroyed, economies would collapse, and the very fabric of societies would be tested. The immediate focus would shift to survival, with nations potentially competing for limited resources. The global economy would enter a recession, the likes of which have never been seen. Recovery would be a long and arduous process, with nations needing to rebuild from the ground up. The psychological impact on humanity would be profound, with the collective trauma influencing generations to come. While it's challenging to predict with certainty, there's a possibility that an impact of this magnitude could threaten the very existence of humanity. The combined effects of immediate destruction, climate disruption, and societal collapse could reduce human populations dramatically. While complete extinction is unlikely, the human race would be set back by centuries, if not millennia. NASA's observations and findings. But what if we had the means to divert or even stop an asteroid collision? The good news is that scientists and engineers around the world are already working on strategies and technologies to address such threats. Over the past few decades, there has been a concerted effort to develop technologies that can deflect or mitigate the impact of potentially hazardous asteroids. One such method is the gravity tractor approach. By positioning a spacecraft near an asteroid, the gravitational attraction between the two can be used to slowly alter the asteroid's trajectory over time. But what if we don't have the luxury of time? Another approach being explored is the kinetic impactor method. Picture a high-speed spacecraft crashing into an asteroid, transferring its momentum and causing a change in the asteroid's velocity. Even a small change in velocity, when done far enough in advance, can result in a significant shift in the asteroid's path, ensuring it misses Earth. Could nuclear devices be the answer? While often depicted in movies, using nuclear explosions to deflect asteroids is a controversial topic. The primary concern is the unpredictability of the outcome. An explosion could fragment the asteroid, resulting in multiple pieces, some of which might still be on a collision course with Earth. However, in certain scenarios, especially with limited time for intervention, a nuclear device might be the only viable option. Early detection is the key. The sooner we can identify a potential threat, the more options we have at our disposal. This is where observatories and space missions dedicated to asteroid detection play a crucial role. By continuously monitoring the sky, we can identify asteroids years, if not decades, before they pose a threat. This gives us ample time to study their composition, structure, and trajectory, and to develop a suitable deflection strategy. But how likely is it that Apophis will collide with Earth in the first place? While the odds are currently low, they're not zero. As of now, the chances of the asteroid impacting Earth in 2068 are less than 0.0001%. However, as we've seen with other celestial events, predictions can change as we gather more data. Still, according to one of the world's leading space agencies, we're safe for a little while. After extensive observations and calculations, NASA announced that Apophis poses no threat to Earth for at least the next 100 years. But what led to this conclusion? The answer lies in the power of radar observations. Radar observations are a game changer in the world of astronomy. Unlike optical telescopes that rely on visible light, radar uses radio waves to probe celestial objects. When these radio waves hit an object, they bounce back, providing scientists with invaluable data about the object's size, shape, rotation, and even its surface features. For Apophis, radar observations were instrumental in refining our understanding of its orbit. Over the years, as the asteroid made its way through space, NASA utilized its Goldstone Deep Space Communications Complex in California and the Green Bank Telescope in West Virginia to closely monitor Apophis. These observations provided a wealth of data, allowing scientists to make more accurate predictions about the asteroid's future path. Then, in March 2021, Apophis made a distant pass of Earth, allowing astronomers to use powerful radar observations to get a clearer picture of its trajectory. These observations, combined with all previously available data, allowed scientists to rule out any impact risk in 2068 and long after. Osiris-Rex, towards a new frontier. But while the world breathed a sigh of relief, another significant event was unfolding in the realm of space exploration. Enter Osiris-Rex, a mission that would further our understanding of asteroids and their potential impact on Earth. Osiris-Rex, which stands for Origins, Spectral Interpretation, Resource Identification, Security Regolith Explorer, was a spacecraft launched in 2016. It had one daring mission: to approach the near-Earth asteroid Bennu, gather a sample from its surface, and then return that sample to Earth. The mission's primary goal was to help scientists understand the early solar system's building blocks and the factors that might have led to life on Earth. But why is this mission significant when discussing Apophis? Because the techniques and technologies developed for Osiris-Rex can be applied to future missions targeting other asteroids, including Apophis. The success of Osiris-Rex has demonstrated humanity's capability to interact with these celestial bodies in unprecedented ways. Imagine the possibilities. What secrets could Apophis hold about our solar system's history? Could studying it up close provide insights that radar observations from Earth cannot? These are the questions that scientists hope to answer in the coming years. And as fate would have it, after its rendezvous with Bennu, Osiris-Rex is set for another significant encounter. In 2029, the spacecraft is scheduled to have a close approach with none other than Apophis. This rendezvous will provide an unprecedented opportunity to study the asteroid up close, further refining our understanding of its trajectory and characteristics. But what can we expect from this rendezvous? For one, it will offer a chance to capture high-resolution images of Apophis's surface, revealing features that might be too small to detect from Earth. Additionally, the spacecraft's spectrometers can analyze the asteroid's composition, shedding light on its origins and potential similarities to other celestial bodies. This can be crucial in informing strategies for potential deflection efforts in the future. If, for instance, an asteroid were found to be rich in certain minerals, it might react differently to deflection attempts than one with a different composition. Mining the cosmos. While the potential threat of asteroids like Apophis has been a significant concern for scientists and the general public alike, there's another side to these celestial bodies that's equally fascinating: their economic potential. While the idea might seem like the stuff of science fiction, the reality is that our universe is teeming with resources, many of which are scarce on our home planet. Asteroids, in particular, are seen as potential gold mines, both figuratively and literally. Take, for instance, asteroid 16 Psyche, which is believed to be so rich in precious metals that its worth could exceed the entire economy of Earth. The idea of tapping into these resources has given rise to the concept of asteroid mining, a field that promises to revolutionize our economy and potentially make earthbound mining obsolete. The basic idea is to send spacecraft to asteroids, extract valuable materials, and then bring them back to Earth or use them in space-based construction projects. The benefits are manifold. Not only could this provide a virtually limitless supply of rare materials, but it could also reduce the environmental impact of mining on Earth. But why stop at mining? Some visionaries see asteroids as potential fueling stations for deep space missions. Certain asteroids contain vast amounts of water, which can be split into hydrogen and oxygen, the primary components of rocket fuel. By establishing refueling stations on these asteroids, we could extend the range of our spacecraft, making missions to distant planets and even other star systems a possibility. Could asteroid mining be the gold rush of the 21st century? Just as the gold rush of the 1800s led to a massive migration and the establishment of new towns and cities, the race to mine asteroids could lead to the establishment of human settlements in space. Companies are already investing in technologies to make asteroid mining a reality. The potential rewards are too significant to ignore. Yet with great potential comes great challenges. The technical hurdles of asteroid mining are immense. How do you extract materials from a low-gravity environment? How do you ensure the safety of such operations, both for the miners and for Earth? There's also the question of ownership. Who gets to claim the riches of space? International treaties currently state that celestial bodies cannot be claimed by any sovereign nation, but they're less clear on the rights of private enterprises. Could the future of humanity be written in the stars? Only time will tell. Thanks for watching this episode of Beyond Discovery. Don't miss the video you see on your screen. You won't believe it.